Assalamualaikum and a very good morning. I'm Adam Ubi.
And I'm Ahmad Daniel. You are watching Good 6 News. For today, we'll be talking about the latest project, which is the Energy Storage System, EAS plant.
The Energy Storage System plant is owned by Evercan and is connected to the Leicester Solar Power Plant, which is in the desert. This poses a problem as the solar power plant is too far away from the city. Therefore, the electrical energy harvested needs to be converted into chemical energy, which is in the form of chemical compound. So it can be transported to the city to regenerate electricity to be used by industrial and residential usage. Now, let us move swiftly onward to Aiman Jupaidin at UTP V3 Cafe so he can proceed with the interview. Aiman?
Thank you, Adam and Daniel from the studio. So I am Aiman Jupaidin live from UTP V3 Cafe presenting about this project. So based on the scenario, the problem statement is that a location of the solar power plant is far away in the desert, so energy harvested cannot be transported directly. And from that, the objective of this project is to determine another way of transporting the energy harvested from the solar power plant, to determine the most suitable chemical compound, and to perform data analysis on the selected compound. So, and apart from that, today we have three contractors with us to talk about their proposed compound. We have Mr. Iyad, Mr. Lukman, and Mr. Harwin today with us. So before we hear about their proposed compound, let us have a brief information about the Leicester engineers' proposed compound, which is octane. Octane is a chemical compound that can be obtained from the methanol to gasoline synthesis, and it can be stored in an approved fuel tank, and it can be transported via trucks, tanker vessels, and pipeline networks. So the problem about octane is that it is not environmental friendly because it releases greenhouse gas emission. So next, let us hear about their proposed compound. So Mr. Lukman, can you talk about your proposed compound?
Okay, so thank you for having me today. So to answer your question, I'm proposing fatty acid methyl ester, or in short, you can call it as FAME. And for the synthesization of FAME, it can be obtained from vegetable oils, animal fats, and from wasted cooking oils through the process of transesterification. And besides, it can be stored in underground storage tanks in cold climates and can be transported through trucks, rails, and barge. So I believe that's all I have for you today. So thank you.
Thank you, Mr. Lukman, for that interesting information. How about you, Mr. Iyad? What compound are you proposing?
As for me, I'm proposing methane because it can be obtained through methanation reaction, whereby carbon dioxide can be converted to methane by hydrogenation reaction. It can be stored in a shell gas reservoir up to temperature 273.15 Kelvin and 50 megapascal. It can be transported in natural gas by pipeline or through LMG by its liquefied form. I think that's all for me.
Thank you, Mr. Iyad. And lastly, we have Mr. Harwin to talk about his proposed compound.
Thank you for inviting me today. So I'm proposing hydrogen as a compound to be used. Hydrogen can be obtained through electrolysis of water by passing electricity obtained from the solar panel. It also can be converted into liquefied and gas form. Hence, it is possible to transport it via pipelines, tube trailers, and hydrogen tube tankers. That's all from me.
Thank you, Mr. Harwin. Back to you, Adam and Daniel in the studio.
So, we are back. Make sure to buckle up your seatbelt as we are going deeper in this topic. Here, we have two guests in the studio. Both are experts in chemistry, Professor Hasnul Hadi and Dr. Tashrukan.
Let's just dive straight into our topic. From all the compound proposed, what are the main comparisons between them in aspect of synthesization and storage, Dr. Tash?
For all of the compounds, each of them can consistently be produced, since the reactants to produce these compounds can easily be obtained. Vegetable oils or animal fats from FAME, carbon dioxide for methane, water for hydrogen, and lastly, biomass or carbon dioxide for octane. Since the solar power plant is located in the desert, ways of transporting these elements for the compounds synthesis would be our concern. Some of them would be quite easy, as they have a steady supply, while others would pose a bit of a challenge. But with that being said, this is not a major concern and can be solved quite easily. As for storage, all of the compounds are well suited to be stored in a variety of ways. Commonly, they can be stored in either gas form, like methane and hydrogen, or liquid form, like FAME and octane.
Alright, thank you, Dr. Tash. Professor Hasnul, moving swiftly onward to you. How about the comparison between all these compounds in terms of transportation and environmental friendly?
In terms of transporting the compounds, each of them has its own method, and it is most beneficial for us to choose the more cost-cutting method. However, one thing to note is that the cheapest method is not always the most efficient. Take hydrogen for example. The cheapest method to transport hydrogen gases is through pipeline. However, since none of the existing infrastructure is actually 100% compatible with hydrogen gases, this means that we might as well transport the hydrogen gases with other natural gases so as to make the transportation more efficient. Lastly, we look in terms of environmental friendliness, and it seems that except for octane, all of the compounds selected fit in this category. This is because none of them actually emit any pollutants. As for octane, however, the synthetic gas from its synthesis can increase greenhouse gas emission.
Thank you so much, Professor Hasnul Hadi and Dr. Tash Ukar. Actually, we have another guest, an expert in thermochemistry, Professor Faruqi. Hello, Professor Faruqi. Can you hear me?
Yes. Is my voice clear though?
Crystal, Professor Faruqi. You may proceed with the presentation.
Alright, thank you Mr. Adam and Mr. Daniel from the studio for inviting me. So, I will be performing the data analysis on the compound proposed. In this case, the most effective method to determine the energy content for each compound is by combusting them. In conducting this experiment, I use bomb calorimeter. The steps of conducting this experiment are: first, using an electronic scale, the water bath is weighed to set the scale to 0 gram and 2000 gram of water and is added into the water bath. Next, using the same scale, a crucible is weighed to set the scale to 0 gram and 1 gram of FEM sample and is added into the crucible. The steel bomb is submerged into the water bath. The steel bomb is then filled with 30 bars of pure oxygen gas. Next, the stirrer is turned on and the temperature of the water is recorded as T1. The ignition wire is ignited as well as the sample was combusted and then the temperature is recorded as T2. Previous steps are repeated to obtain data for methane, hydrogen, and octane. So, from this experiment, here are the data on the experiment. We found that FEM has the highest enthalpy value, and the following are the decreasing order of enthalpy, which are octane, methane, and hydrogen. A bit on calculation on how do I get the final value of each compound. To calculate the enthalpy, I use this formula, which from the application of the energy conservation, we can calculate the enthalpy of each compound by calculating the heat surrounding. And this is the balance equation for each compound. And finally, these are the calculation to get the value of enthalpy of each compound. Firstly, FEM, next is methane, next is hydrogen, and finally octane. From the data given by the contractors and from the experiment, FEM seems to be a better option based on enthalpy value. However, knowing that alone doesn't convince us fully decide that FEM as compound to be chosen for this project. Another factor to be considered is the entropy of a reaction, which will determine the spontaneity of a reaction. To know the spontaneity of a reaction, we must base it on the sign of delta G. If the sign is positive, the reaction is non-spontaneous. Meanwhile, if the delta G is negative, the reaction is spontaneous. The calculation to find the spontaneity of the combustion reaction of FEM is as shown. From the equation, the sign of delta H is negative. The sign of delta S is positive because the total number of moles of gas molecule in the equation increases from 23 to 32. From that, we can predict the sign of delta G as shown. Since the delta G will always be negative regardless of the magnitude of T, this means that the combustion of FEM will always be spontaneous regardless of the temperature. All in all, I'm convinced that FEM is the most suitable compound to be chosen for this project. So, back to you, Mr. Adam and Mr. Daniel at the studio.
Thank you for such detailed explanation on the data analysis for each compound, Professor Faruqi.
Now that we have all the data necessary to make the decision of which compound to choose from the selected ones, we found that the best compound to be used to store energy is the fatty acid methyl ester, FAME. Based on the calculation of the enthalpy of combustion for each of the compounds, FAME has the highest value out of all 4 compounds, which is 9556.41 kJ per mole, including the fact that it can be synthesized easily by the process of transesterification of animal fats or vegetable oils. This method is also environmental friendly because there are no byproducts resulted from the process.
Aside from that, the storage and the transportation options for this compound are mostly cost efficient. In conclusion, we are confident that fatty acid methyl ester is perfect to be used as the energy storage compound. That is all. Thank you for tuning in.
Ciao.